Hey, 6th grade, this is Lesson 8, Day 2. So today you are going to explore the two ways to do division. One with the partial quotients method and one with the regular division algorithm. So what we're going to do is on page 84, which if you're not here, pause the video and go get your book. But we're going to read this problem and we'll show you the different ways that you can divide. And then on the next page, you're going to be comparing the two different ways. All right, so let's start by reading the problem here. And it says, a family is heading out on a car trip of 672 miles to what is known as the sixth most popular national park, the Blue Ridge Parkway. If they travel there at an average of 56 miles per hour, how long will it take to get there? So first, how would you know this is division? Well, if the total trip is 672 miles, and they travel there at 560 or 56 miles per hour, what you're doing is you're splitting up the 672 miles into groups of 56. And how long will it take to get there? Well, that's how many groups of 56 you have. So anytime you're splitting something up, it's going to be division. This is going to be 672 divided by 56. Now, the first way we're going to explore is estimating. So this says you can use compatible numbers to estimate the quotient. So here's what they mean by compatible numbers. If I take 672 divided by 56, I can estimate this in different ways. So for example, one is maybe I make this 60. It's definitely a friendlier number. And if that's a 60, and I want to look at that 6 specifically, I could say 66 is really close to 67. So I'm going to make that 660. Now here's why this is kind of an easy way. Is 66 divided by 6 is 11, and these zeros don't do anything in division. They just cancel and go away. So that would be a good estimate. Now some people might say, you know what, I'm just going to make it 600 divided by 60. And if you do 600 divided by 60, that 0 cancels, that 0 cancels. 60 divided by 6 is 10. So either way, 11 is a closer estimate, but 10 isn't that bad either. Notice they're both kind of close. So we know it's going to take them about 10 or 11 hours to get there based on our estimates. So that's compatible numbers. Compatible numbers, you don't want any remainders in your division. You want to be able to do it in your head. All right, now let's talk about partial quotients. So we have to divide 672 by 56. Now when we do partial quotients, we want to use easy numbers. So for example, I know that 56 times 10 is 560, because multiplying by 10 is really easy. So if I say 56 goes into 672 at least 10 times, which is 560. Then I subtract, I get 2, 1, 1. I have 112 left. Now I also know 56 times 2 is 112. So I could say 56 goes into 112 two times, which is 112. Subtract 0. Now, to combine your partial quotients together, add those two numbers, 10 and 2 is 12. So my answer is going to be 12 hours. So that's partial quotients right there. Okay. Now, if we go down to the model it using the traditional division algorithm, and you're going to notice some similarities as we do this. So first off, you would say 56 goes into 67 once, which is 56. Now, because that 1 is in the tens place, you're really saying 56 goes into 672 10 times. That 1 is 110, which is 10. Now, what I do is I subtract 67 minus 56. I get 11. Now, keep in mind, that's 11 tens, also 110. And I bring down these two ones. Okay? And then I continue. 56 goes into 112 twice, which is 112. Subtract 0, and I get my answer, 12. All right, so there are the two methods, and you get the same thing, 12 hours. Now what I'm going to do is erase all this, and let's take a look at all the junk that the book has written there just so you can see. So in partial quotients, I'll get my pointer ready. These were the partial quotients, the 10 and the 2. Remember, 56 times 10 was 560. And the 12 was the 2. 56 times 2 was 112. And we added the partial quotients to get the answer. Now here, when you said 56 went into 67 one time, this was actually 56 tens, okay? Now, this 112 minus 112, this is 112 ones, and you get 12 as your quotient. Okay, so now, on the next page, here's what you are going to be doing. You are going to pause the video, and you're going to answer 2 through 7 on your own. Now, if they say to explain, explain. A lot of them are going to ask you to compare the two methods on the previous page. If you're not 100% sure, just give it your best shot. You can always change it after you restart the video and go over it with me. All right, so answer 2 through 7 now. Pause the video. When you're done, restart it. Go. All right, so let's see how you did. So we are now going to go over 2 through 7. You should have these done. And remember, anything, if you had it wrong, you can fix it now. So 2 says, why does it make sense to use 660 and 60 to estimate the quotient? Okay, remember, the original problem was, I forget, it was 672 divided by 56, right? So the original problem was 672 divided by 56. So the reason we would use 660 and 60 would be they're close to the original numbers and they're easy to divide mentally. So I'm going to write that down. Okay? The numbers are close to the original problem and easy to divide. If the numbers aren't easy to divide, it's not a good estimate, right? You're supposed to make it so something that you can do in your head. All right, you don't need my exact words, but if you, that's kind of why you change it to those numbers, all right? Now 3 says, how is writing the 1 in the division algorithm the same as writing 10 in the partial quotients model? So let's go over and look at it, writing the 1 in the division algorithm and the 10 in the partial quotients. All right, so in the division algorithm, let me switch to purple. When you write the 1 here, how is that like writing the 10 here? Well, remember when we did 56 times 10, we got 560, right? Okay. Down here, when we said 56 goes into 67 56 times, well, that's actually not a 1. Because it's in the tens place, it's a 10, right? See how 1 is in the tens place? So they're kind of the same thing. So if I explain that, I would say the 1 in the division algorithm is actually 110. So it's the same as 10. So it's actually the same thing, right? Okay. So if you had that wrong or you weren't sure, you can write down my answer. But if you had something in your own words where you're like, okay, that 1 is actually a 10 in your own words, you are good to go. And remember, you can pause this anytime you need to make corrections. Now 4 says, how is writing 56 in the division algorithm the same as writing 560 in the partial quotients model? So let's go and look over here. Let me erase some of my junk from before. So how is writing the 56 here the same as writing the 560 here? Well, I want you to take a look at in the division algorithm. When we write the 56, it's actually, you see how it's underneath the 67, which is hundreds and tens. So that's actually 67 tens. So this 56 isn't 56, it's 56 tens. And 56 tens equals 560 ones. You just add the 0 on the end of the 56. So in the partial quotients, you actually just show the whole 560 ones. So Let me go over and explain this. So how is writing the 56 the same as writing the 560 in partial quotients? Well, similar to number 3. The 56 is actually 56 tens, which is the same as 560 ones. Okay? So remember, if you had something similar, you don't have to change your answer. But if you weren't sure, you can always write mine down. You could pause the video. All right, now number 5 says, when solving this problem with the division algorithm, how is bringing down the 2 ones like the first subtraction step in the partial quotients method? So we're going to compare bringing down the 2 ones to the first subtraction step in partial quotients. So let's go back over here and find it. All right, so down, let me erase all the junk. When we bring down the 2 ones right here, okay, we are comparing that to the first subtraction step right here. Okay, so up here, I'll explain in the division algorithm. So remember, let me white out some of this stuff and make it easier to see. I should have it on thicker pens, taking too long. All right. Okay, that's better. So remember, in this one, remember how this was 67 tens minus 56 tens was 11 tens. Now, bringing down the 2 is just saying if you combine 11 tens, 11 tens is the same as 110 ones. And you're just bringing down that 2 to say it's 112 ones. That's what you're really doing there. So this 11 was 11 tens plus the 2 ones is 112 ones. So up here when we do it, since we're dealing with all these are already ones, we have 672 minus 560 is 112 ones. Okay? So that's kind of the difference there. So when I go back here, I'll explain it. Say bringing down the 2, the 2 with the 11 tens is 112 ones. Okay? This is the same as subtracting, I'm going to say in partial quotients, in PQ. PQ is going to stand for partial quotients. As subtracting and getting 112. Okay? So, that's kind of confusing to explain, but that's really the difference. Now, number 6 says, how long will it take the family to drive to the park? Well, it will take, we figured out the answer was 12 hours. And it says, how can you check your answer? Well, you can check your answer by using multiplication. So remember, we said 672 divided by 56 equals 12, right? So you can multiply 56 times 12 to see if you get 672. So I'm going to do that now. I'm going to do 56 times 12. So 56 times 12. 2 times 6 is 12. Carry the 1. 2 times 5 is 10. Plus 1 is 11. Fill in my 0. 1 times 6 is 6. 1 times 5 is 5. Add those together. 2, 7, 6. Holy cow, I got 672. So that's how you can check any division problem. Just multiply. All right? Now, number 7 says, how is using the division algorithm to divide the same as using partial quotients to divide? How is it different? Okay? Well, I would say it's the same because a lot of the numbers you get are the same. All right, but it's different because, I don't know, how is it different? Well, you kind of follow different steps. All right, so I'm going to write an answer. I'll pause it, but you don't have to. You can write your own thing here. Don't erase your answer, as long as you told me how it's the same and how it's different. So I'll write mine real quick. Okay, so here's my answer. They gave me more room. You can go into a lot more differences, but all I said is they are the same and that many of the numbers are the same. And what I meant is you see a lot of the same numbers, the 112, the 112. The 5610s is 560 over here. So you see a lot of the same numbers. Now I said they are different in that the steps involved are different. It's kind of vague, but you know, I just mean when you follow them, you do different steps here. This is you subtract, you have this, all the numbers are in ones, we're over here, so they're tens. So, you know, the steps are just different. So don't get too hung up on that one. Now, for the try it problems, here's what you're going to do. You have two problems you have to solve that are division. So what we're going to do is I would like you to solve 8 and 9 using the method that you choose when you are doing it on your own. But when I go over it, I'm going to do partial quotient and I'm going to do the division algorithm. Whatever way you didn't do with me. All right, so you're going to want to get a separate sheet of paper. So your first step, if I gave you too much information, is do 8 and 9 on your own. You'll pause the video and do whatever division method you choose. All right? Pause the video. Go. All right, so you should be done with 8 and 9 now. Now, as I go over 8, I'm going to do partial quotients and the division algorithm. So whatever method you did, check as I go over the video and make corrections. But then when I do the way you didn't do, I want you to do that with me so you can kind of get a taste of both methods. All right, so I'm going to start with the division algorithm because I think most of you probably did that. So a grandmother has $490 that she wants to give to her 14 grandchildren. How much money will each grandchild receive if they receive an equal amount? So what grandma's doing is she's taking the $490 and she's splitting it into 14 equal chunks. That's how you know it's division. So in the traditional way, we'll start here. Now remember, if you did partial quotients, I want you doing this method with me now. If you did this method, just check it as we go. So first off, I need to figure out what 14 goes into. It does not go into the 4, but it will go into 49. Now to figure out how many times, I usually count over here. So 14, 28 plus 14 is 42, 56. Okay, so it's going to go in 3 times, which is 42. Subtract, I get 7. Now remember, that's not 7 ones, that's 7 tens. Bring down the 0, so now I have 70 ones. Now how many times does 14 go into 70? Let me continue my list. So 56, one more is 70. So it's 1, 2, 3, 4, 5 times, which is 70. Subtract 0. So how much will each grandchild receive? Each grandchild will receive $35. Now, if you made any mistakes and if you did that method, make sure you fix them. But now, if you didn't do partial quotient, I'm going to do that now. I want you to do it with me just to get a taste of how they're different. So first thing, I'm going to write same problem, 490 divided by 14. And if you do partial quotient, there's lots of different ways you can start off. So I'm going to start off, for example, see these numbers I used over on the left? Well, I'm going to kind of use those because if I know 14 times 3 is 42, right? That means 14 times 30 is 420. So I'm going to start by saying 14 goes into 490 at least 30 times, which is 420. I'm going to subtract and get 70. Then I'm going to say 14 goes into 70 5 times, which is 70. Subtract 0. combine my partial quotients together, and I get 35, because 30 plus 5 is 35. All right, so remember, one of those ways you did on your own, one of those ways you did with me. Okay, you ready for number 9? Let me get number 9 ready. Okay, so now I have number 9 focused. So it says 18 students each collected the same number of cans for a project. If the students collected a total of 306 cans, how many cans did each student collect? So here's why it's division. You are taking these 306 cans and splitting them up for the 18 students because each student collected the same number of cans. So 306 cans split into 18 groups. Now, I'm going to do it the two ways. Remember, just like before, whatever way you did, correct any mistakes you made, and whatever way you did not do that way with me. So for number 9, I'm going to start with the traditional division algorithm. So I'm going to do 306 divided by 18. And I'm going to start a little bit of a counting by 18 list. So I have 18, and I'm going to do a little math over here. 18 plus 18 is 36. Plus 18, 6 is 14, is 54. I'll do one more for now. Plus 18, that's 12, 5, 6, 7, 72. Now, I'll add more if I need them later on. So right now, to start, 18 goes into 30, doesn't go into 3, goes into 30 one time, which is 18. Okay, subtract, I get 12. Remember, that's 12 tens. Bring down the 6 to make it 126 ones. Now I'm going to continue my counting by list. So I have 72 plus 18 is 90. Plus 18 is 108. Plus 18, 8 and 8 is 16. 2 is 126. All right, so I have enough to finish this problem off. So now 18 goes into 126. 1, 2, 3, 4, 5, 6, 7 times, which is 126. Subtract 0. So how many cans did each student collect? The answer is 17 cans. Now, what I want you to do, if you did the traditional division algorithm, I want you to make sure if you made any mistakes, you fix them. And notice how I did my counting by 18 list by adding 18 on each time. That's one method. I like to have the list of numbers here because I can use them. Now, I'm going to use that same list as I do partial quotients. So be ready. If you didn't do partial quotients, get ready to do it with me. So I have 306 divided by 18. Now I know 18 times 10 is 180. So I'm going to say 18 goes into 306 to start 10 times, which is 180. I'm going to subtract 6, 2, 1. I'm down to 126. Now 18 goes into 126 if I use my list 7 times, which is 126. Subtract 0. Combine my partial quotients, the 10 and the 7 together, and I get 17 cans. All right, so kind of do that with me just so you can get a taste of both methods. And remember, whatever method you like better, go with, but don't be afraid to try a different method because it never hurts to learn different ways to solve a problem. But guess what? You're done with me for this video. And as always, thank you for watching.